Hi, everybody. I'd like to take a look at these words, resource, abundance, and design. That's what we're here to talk about. And I've had the opportunity to work with German chemist Dr. Michael Braungart, and we've written Cradle to Cradle and then The Upcycle. And what we're looking at is a world of good. And how to do that by design, because I see design as the first signal of human intention. And if we intend to be less bad, perhaps we'll still be bad, just less so, by definition. So what would it mean to be more good? Let's start with a poem from the 12th century. Glance at the sun, see the moon and the stars, gaze at the beauty of the earth's greenings, now think. Glance, see, gaze, think. She goes on to say, what a delight God gives to humankind with all these things. A delight, beauty, wonderment. And then, all nature is at the disposal of humankind. This has been part of our thinking. We are to work with it, for without it we cannot survive. This turns into sustainability and use of the natural world. But when you think about sustainability, if I asked you what your relationship was with your loved ones, and you said, sustainable, I'd say, I'm sorry. It doesn't sound that interesting. Now, I was born in Japan in a traditional Japanese house, and as a baby at 3 years old, I would lie on a futon and I would listen to the ox carts as the farmers collected our sewage. And they would take it to the farms. This is the Netherlands. And the cities and the farms were always one organism. And I always thought, isn't this great? Poop stories. The farms and the cities are one thing. And this is a city that I heard about as a 5-year-old, which is Hiroshima. And then I heard about this city that took thousands of years to build, took seconds to destroy. It takes thousands of years to build. It takes seconds to destroy. And I thought to myself, someday I'm going to understand why people might do this to each other, and how is it even possible to do this? So when I was 19 and I was in college, I decided I wanted to study international relations, which I did, but then I wanted to understand how this could even happen. And so the professor in physics said, you must understand the special theory of relativity because the answer is there. And then I realized that if C is a huge number approaching infinity and square it, it's gigantic. And if M is a 1, like in one hydrogen atom, then the E is gigantic, and that is the atom bomb. And a tool's value is put there by the purpose to which the human puts it. Design is the signal of intention. And then I stared at a fire burning, and I thought about entropy, and I said, so all we have is this chaos of carbon and minerals and water that never can reaggregate? Is that what we're learning? And I said, there must be negative entropy, because I'm from Asia. We must have the opposite. What would it be? And I couldn't find it in the physics library. I found exergy, enthalpy, I found lots of things, but not negative entropy, until I realized that what's happening here is the carbon is going into the atmosphere, the oxygen is coming down, and the reason I couldn't find negative entropy in physics is because, from a design perspective, it's biology. That's why. These are the aggregators of dissimilar things that have been dispersed. There's the CO2. Nature has found a way to take CO2 out of the atmosphere and put it in soil. And you realize that the only income on the planet is actually solar energy, carbon, and some nitrogen, and that we release oxygen. Isn't that amazing? And so you start to think that E and M, E is physics, M is chemistry, and what about biology? So I studied Francis Crick. After discovering DNA, 9 years later, he wrote an essay for the University of Washington called The Nature of Vitalism. He determined in order to be a living thing, you had to have 3 conditions: growth, income, and an open system of chemicals operating for the benefit of the organism and its reproduction. This is fascinating. This means the M, the mass, is precious, and that it's all we have except for bits of income here. So let's treat the mass preciously. And that's when I realized if I ever became an architect, for example, I was an art student, I will design buildings like trees. So I designed a daycare center in Germany where the children would operate it, would grow its own food, make its own energy, provide community laundry, But I was sitting with the daycare center teachers programming it, and I saw that the children were eating the building. So I thought, well, wait a minute, what are they eating? So I decided to find a chemist, which I did, Michael Braungart, and we started to look at what about these chemicals and what's going on with this open system of chemicals. And we realized that if we could design materials like Crick is talking about, the biosphere of waste equals food, an open system of chemicals operating for the benefit of organisms and their reproduction, the humans in the last 5,000 years have developed another metabolism, which is the technical one since we started banging metal. And that these both metabolisms can operate for the benefit of our species and the reproduction of all species and biodiversity. So we design into these two metabolisms. Now, humility is required because for 5,000 years, we never figured out how to put two wheels on our luggage. So we're not as smart as we sometimes think. But then when we started to think, what if we design materials that can go back to nature safely, the things we wear, the things we use in water, and then things as technical nutrition that go back to industry forever, the polymers, the aluminum. Since 1850, 75% of the aluminum made by humans is still in circulation. Technical nutrition. Think about this. Even solar collectors, even if we use cadmium, could be seen as being nutrition for technology of the future as long as they're safe. My first product was a textile where we brought the chemists in and we looked at the rivers in textile mills, this one in Indonesia, and we said, wait a minute, the river is black and it's toxic. Really? So we redesigned it. We looked at 8,000 chemicals in the textile industry, reduced it down to 38 for wool and ramie, and made a fabric so safe, the water coming out of the mill, which goes to Lake Constance in the Alps, is clean as Swiss drinking water. Why not? Because we can do this by design. Isn't that astonishing? And the trimming, which used to be hazardous waste, became mulch for the local garden club. The company no longer had to send it to Spain for burial or burning. Imagine. So we took a look at technical nutrition. This is carpet. Carpet in the United States, we have 1.4 billion pounds of carpet waste in the United States every year, some of it PVC, very hazardous material to handle. And so we started designing, this for Berkshire Hathaway, is now the largest carpet company in the world. Technical nutrient skins, face yarns, back to caprolactam. The back is a thermoplastic polyolefin, so the carpet becomes carpet again forever. You're storing your materials on your customers' floors, and they can be used ad infinitum to make carpet over and over again. That's it. We take these materials, we put them in a materials bank. You have a relationship with the customer, which is perpetual. Now, right before the Earth Summit, a book came out that struck me because I was writing the Hanover Principles and Design for Sustainability, and it was a book called Ecocide in the USSR. It pointed out that 16% of the former USSR was uninhabitable. Toxification. And this is what we're looking at in terms of its arable land, 50% imperiled. Now, what does that take us to today, for example? Here in China, a couple months ago, this was announced. China has about 12% of its land is arable. Of that 12%, just now, this is government statistic, 19.4% has been declared contaminated, too toxic to grow food. 20%, imagine that. And what is it? It's cadmium, it's lead. It's the materials that we use to make things like this. Well, are cadmium and lead bad? No, they're materials. If we use them as solder, they're busy over there. See, and if we sequester them in technical nutrition, we can use them ad infinitum. But when they get in the biosphere, they are neurotoxins, mutagens, carcinogens, and so on. This is Hunan province. This rice should not be eaten. What is a toxin? A toxin is a material in the wrong place. Lead in a computer is solder. Lead in a child's brain is brain death. Okay, so when did we decide that carbon was a toxin? Imagine, we are carbon. If you don't like carbon, shoot yourself, dry up, and blow away, because you are carbon. All right? So when did we take carbon from the atmosphere that's been made into an asset over millennia and turn it into a liability? Well, we did it by sending all the ancient carbon back into the atmosphere. Whoops, backwards, upside down. And then all of a sudden we get the greenhouse effect, and now carbon has become a toxin. We did that. Did we do that on purpose? I don't know. Was that our design? If it's not our design, who's got the plan? So the question becomes, can I bring carbon and nitrogen to the soil? Can we release oxygen by design? So I was asked by NASA to think about designing the space station for Mars. And I said, before we go to Mars, what if we come back to the blue planet first? So we got this team that developed the design of the space station. And we got together in Houston and started in the room where they heard the words, Houston, we have a problem. So we started there. And this team, these are people who nuclear powered a station with nuclear energy coming from a reactor 93 million miles away, a safe distance, 8 minutes, and wireless. Isn't that interesting? So we took that team and designed a building, and here it is. It's in Mountain View, California. This building can make 120% of the energy it needs from renewable power and purify its own water down to the last molecule. And we did it with a normal federal budget for an office building ahead of schedule. So let's not just talk about more efficient buildings. Let's talk about buildings like trees. We want more of them. And the problem is so many people today report their environmental behaviors, etc., as let's be less bad, reduce our carbon emissions by 20% by 2020. If you're telling us you want nothing, well then why don't we go and put it below the line? Because wanting nothing is like saying, if I run out of here and jump in a taxi and say, quick, I'm not going to the airport. Is this helpful? We're not telling people where we're going. So let's start saying, we'll get rid of the bad stuff. Let's start doing the good stuff. What does the good stuff look like? So it's not just reduce your badness. And so we do an inventory. If it's materials, we do every molecule. We don't want them accruing in mother's milk. If it's energy, we want it clean and renewable. If it's water, we want it safe and healthy. So let's take a look at all these conditions that we have today over here in these various things. And let's not just shrink their badness and report that we've reduced our emissions. Let's start to increase the goodness. Let's start focusing here too. We do both. Out with that stuff, in with this stuff. It's about constant improvement. So the idea of our upcycling is that things get better every day, not just less bad. And it doesn't mean don't do this reductivism. It means also send a positive message to the children that we have an idea of what the future might look like by design with good intention. And so just as we look at that and close it, I'd like to think about what it means to have carbon, for example, once again become an asset for humans instead of a liability. And we'll start with that because so many people are concerned on the carbon front. So, Mark, show us how you do that. Thank you. This product is now going through cradle-to-cradle certification review, which is very exciting because it's the design for the circular economy. We look at materials that are nutrients. We look at materials that have reverse logistics, new business models, new ways of getting these materials back into cycles. We look at essentially waste equals food, and that everything is food for something else, technology or biology. And we take the old paradigm of take, make, waste, and we reverse it. In this point in history, see, God never sent a bill for the trees. So what can we do in the future where we can get materials cheaper than free? Think about it. So when we stop and look at just, I call this either or, and the or is with an E. You can either get mining of the earth, if you're looking for gold, and you make about $210 per ton on the gold. Or we could mine circuit boards from old telephones, and we get about $7,500 per ton. So, what if we mine the cities? What if we mine the things we make now, and we start designing the things we make now for what's next? So we design what's next into what's now, and we understand how they relate to ecosystems and organisms. This is a sewage treatment plant. That is sewage sludge. A mechanic working with that discovered the pipes are all clogging up with minerals, so he sent them through in a vortex, and guess what happened? That happened. This is known as struvite. That is phosphate. It is a slow-release fertilizer that can be sold at a 12% profit. So all of a sudden we realize that sewage treatment is silly. We take these valuable nutrients in the biosphere, add chlorine, and throw them in the water. All right, what if we turn that into fertilizer for farmers? Nitrogen, phosphates. We all need 3 to 4 grams of phosphate per day. Where are we going? Kazakhstan, Morocco for this? When they're right there in our cities. So when you start to think about it, imagine Paris with roofs covered with farming, just for conceptual purposes. Imagine Washington, D.C. being highly productive. Isn't that interesting? So we start to think about what would a city, this is a one-day sketch, saying, well, wait a minute, what would buildings be if a city grew its own food? How can we start to think about those things? And I did the project for the Ford Motor Company to revitalize this 1,000-hectare site known as the River Rouge in Detroit, and we ended up doing the world's largest green roof. And when you stop and think about it, this building is making oxygen, purifying water, and it saved Ford $35 million in CapEx day one over conventional chemical systems, which means it's the equivalent of walking into the board to get permission for this and saying, I have the equivalent of an order for $900 million worth of cars at a 4% margin. Brad Pitt and I looked at New Orleans and decided to see if we could help after the Hurricane Katrina. 10,000 people were displaced here. So we went and looked and met with the community, started a foundation called Make It Right, and started working with the local residents to see what it meant for them to come home. And we decided to build a neighborhood of 150 houses. We're at about 103 now. And we hired architects from around the world, local to international, and we gave the people choices of many designs, and they could choose their own. But what I love the most is the children came back from the FEMA trailers with asthma because they've been surrounded by formaldehyde. And these kids want to sing and dance. This is New Orleans, the home of the first original American music. And if these children can't sing and dance, there's something wrong in the world. And so these people have a $400 mortgage, they get their power from the sun, they can afford to give the kids dance and singing lessons. And the great thing is the children came back, they couldn't breathe. Now they can breathe. This is a project in the Netherlands that is designed to make its own food, power itself, and these are office buildings selling in a market where office buildings can be bought for 1 year's rent. And it's because people want to be in places like this, and the buildings are seen as material banks that are storing materials for future generations after design for disassembly. It's worth about 1.4% in the financing pro forma. It's this project here. As a result of this, we've just been given this near Schiphol, if you can imagine the scale we're dealing with here. And what we're looking at is this massive project where logistics are here, biology is here, and in a way, the conceptual framework is technical nutrition, biological nutrition. This will be a cradle-to-cradle hub for the circular economy. Companies and people can come here. I wanted to look at Pakistan and Haiti when these disasters occurred because we wanted to help. And it occurred to me after hearing from Muhammad Yunus from Grameen Bank and some friends, they said, Bill, you've got to take on the housing issue for the super poor. And so I started to think, well, if we're going to have the first industrial revolution using natural resources, what are we using in the next one where we can afford the materials? And so I realized this is material. These are sachets and packaging, and we say, oh, we're giving the poor these little packages, isn't that wonderful? And yet, this is it. Wait a minute. Is that all we got? So I thought, well, let me do some conceptual work. What if these relief situations actually produce capital formation of things that people could use again and start to create communities that are actually viable in the short term, but also could be disassembled and used as resources over the long term and could adapt to local cultures depending on what you want to do with the building systems. So we started to look at, if you think about a resource like plastics from New York, where the films are the bulk of it, and they're paying $80 a ton to get rid of it. So I decided my design team would be sixth graders. So we brought together the children to start to think about designing towns, and I've got to tell you, I'd rather live in this than most of these little barracks-like refugee camps, frankly. And so we started to think conceptually, what if we could take these materials and people could build a house in one day with their children without tools? And we started to think about what the systems could be like that would allow that kind of thing to occur. This house, since it has a dignified core, 10 feet tall, you could add wings to this or surround it. It becomes 8 bedrooms if you want. And so we have the children laying out streets and groups for housing. This is just the sort of bulk version of it. It's very refined now. But even things like that window are just flipping out on a spring, so they don't require complex mechanisms. And we started looking at using these polymers to make various kinds of plastics, parts the kids can put together to build houses. We have 8 joints coming together in a flat space. They just put a rivet and away we go. We have unfolding roofs for smaller buildings and mushroom insulation, believe it or not, as we experiment in different ways to do things in biosphere and technosphere. The styles of the houses will be up to the people. This is building systems. So in the United States, we use 2x4s and plywood. What if we had different sized parts? And the commercial model is based on an inspiration by this astonishing person, Dr. Venkataswamy of Madurai, India. And he was a cataract surgeon who realized that if he went to mass production, that he could reduce the cost of it all. Instead of $300 lenses, they'd be $2. Instead of $1,900 for cataract surgery, it could be $20, which it turned out to be. And because of that, he could give it for free to the people who couldn't afford it, and the people who could afford anything would pay $50, $60, $80. That's it. And in his legacy of this hospital system, he has given eyesight to 2 million people for free. This is astonishing. And so what it does is change the question of commerce itself from how much can I get for how little I give, a world of limits, to one of generosity and abundance. How much can we give for all that we get? A world of generosity, of fairness. And as we look at the entropic activity of the burning of the world, those light bulbs you see are fires. They are fires. Mark is right. And we can look at all alternate systems. Of course we can. We can think about what more good looks like. But at the same time, as we celebrate, we should remember all of these things here are chemicals. And they all come back to the ground. And as we think about rising into the sky, we also have to remember what it means to come down to the ground and get grounded in fundamental principles that drive our design. And as we think about the world, let us see the world. Let us glance. Let us see. Let us gaze. Let us think about this beauty. But let's remember what we need to do now is start with our children to think again about the future. So let us think. After we think, let us do, because it's time for action. And I think with these kinds of protocols, we can now get to work once again. Thank you very much.